algorithm. This is a gravitation search algorithm. It's based on its physics algorithm, in which we use it's based on Newton's laws. Basically, two masses when they attract each other. That's how this gravitation search algorithm is working on. In this, we first initialize the agent, and then we work on the fitness value, and then in the third step, both the masses attract to each other. That's how the gravitation search algorithm works. And in this, we compute the mass and we update the positions as we do it in any physics problem based on gravitation. The common advantages of GSA algorithm is it's a simple concept based on physics, and it is good global search and scales well for medium to large problems, and flexible and can be combined with PSO and GA. The disadvantages of GSA algorithm is its slow convergence rate. It's very difficult to compute the values and the masses when it is working in a slower condition, and affects the value. And then it is computationally expensive. It takes a lot of financial support for this to in order to carry out. And the parameter tuning is very hard in this because it requires a lot of patience and it requires a lot of time for the GSA search algorithm. And this is based out of inspiration from nature inspired as well. Now my friend uh, Vagish will take over the rest of the part of the gravitation search algorithm.
Alright, moving on to a simple example, if we consider a sphere function, if we consider that's like f of x is equal to summation of x squared, xi squared. So this is a function that suppose we presume the optimization for this can be done easily using GSA algorithm. So what we are aiming to find here is the value of x that minimizes this function. So in simple words, we want to find a point in the space where the sum of the squared numbers is the lowest at that point. So the function, like obviously, it's like you're looking at the function, the global minimum is found at x is equal to zero, where like the function value will be zero itself. But this is mathematically. Instead, we can use gravitational search algorithm to solve this. And the way we do it is in a couple of steps. One, we initialize the random agents, like positions like 3.4, 1.2, like all random numbers we generate. We calculate the fitness of these, basically finding the sum of their squares. Then we find the best agent by calculating the highest mass, just like how we do it in gravitational search in physics. Once it is done, all the reagents are pulled towards the main mass. Like, say, suppose the highest mass was 5.6. All the other masses, like the weighted masses, will be put up near it. And over the iterations again and again, the swarm collapses towards all the zeros. So, like, once we have convergence towards zero, we reach the minimum point. And as my friend Aditya clearly explained, convergence is slow because moving on from a higher dimensional value to flattening to zero is something that takes a lot of time. The way we can like use this is having a lot of more opportunities in the future for like using gravitational search algorithm, which is comparatively faster when we look up for any basic searching algorithms. Now, and that's the gravitational search algorithm, which is simple, elegant, and powerful for optimization problems. And this should pretty much sum up the actual essence of the algorithm, where it can be used in diverse fields like machine learning for simpler fitting of higher dimensional models, for flattening deep learning models, and mainly it can be computed for all the searches in the since it's nature-based algorithm, it's further useful for building any real-life projects and applying this in a very streamlined fashion. Thank you.